So class 12 solutions chemistry chapter 1. So this is part 2 of the video. Part 1 I've already discussed and solved questions based on molality, mole fraction. So in this lecture the topics to be covered are solubility of solid in a solvent, like dissolves like, polar and non-polar solvent, dissolution, crystallization, dynamic equilibrium, effect on temperature, effect on pressure, Henry's law, Dalton's law, and partial pressure. So let's begin. So solubility of a substance is the maximum amount of solute that can be dissolved in a specified amount of solvent at a specified temperature. So if the temperature remains constant, amount of solute dissolved in a solvent is known as the solubility of the substance. It depends on the nature of solute and solvent as well as temperature and pressure. Solubility of solid in a liquid. Solubility of solid is solute, liquid is solvent. So number of solute dissolved in a liquid. Like dissolves like. What does this mean? Polar solute dissolves polar solvent. Sugar is a polar solute, will dissolve with the polar solvent, that is water. A molecule is considered polar when it has separation of charges, that is, one end of the molecule will have partial negative charge and the other end will have partial positive charge. Example, hydrogen fluoride. Now hydrogen fluoride, here we can see that fluorine is highly negative, so it attracts the negative charge towards one end of the molecule, or the negative charge is accumulated at one end of the molecule. Other end of the molecule is hydrogen, which is positive. So you can say that the cloud of electron is not properly balanced in the molecule. One side it is having more of electron, other side is having less of electron. Such a molecule with imbalanced charge is known as polar molecule. So if solute and solvent are polar, they dissolve easily. Similarly, if the solute and solvent are non-polar, it will also dissolve easily. So that's the reason like dissolves like. So naphthalene do not dissolve in water but dissolve in benzene, as both are polar. So naphthalene and benzene are non-polar, hence they dissolve, but naphthalene and water is one polar and non-polar, so it is not like, hence it doesn't dissolve. So when a molecule have no partial negative or positive charge on either side, but the electrons are evenly distributed, it is called nonpolar. So what is nonpolar? The electrons are evenly distributed. So here chlorine and two chlorine atoms both share negative charge, and it is not accumulated at any either side. It is evenly distributed. Hence it is nonpolar. Next, dissolution. So when a solid solute is added to a solvent, some solute dissolves, rising the solution concentration. So when solute dissolves in solvent, what happens? The solution concentration rises. Now instantly not all the solute will dissolve. Some of it is still not dissolved. So the amount of solute which dissolved, rising the concentration of solution, is known as dissolution. So here the solvent with black dots, solute with red dots. See, some of the solute got dissolved in the solvent, and this dissolution of solute in solvent is known as dissolution. So solute plus solvent is dissolving the solution, rising the concentration level of solution is dissolution. So crystallization, when some solute particles collide with the solid solute and get separate out of the solution, it is called crystallization. So in this diagram you can see that the solute is colliding with the solute in the solution, and some of the solute is coming back to the undissolved form. This is known as crystallization. So solute plus solvent from the solution is coming back. It is no longer dissolved in solvent. It is called crystallization. What is dynamic equilibrium? A stage when the rate of dissolution equals rate of crystallization. It is called dynamic equilibrium. So equilibrium is equality. So amount of dissolution or amount of solution, solvent dissolving solute is equal to the amount of from the solution solute is coming out. So crystallization. So the amount of crystallization equal amount of dissolution. Such a state is known as dynamic equilibrium. What is saturated solution? When no more solute can be dissolved in a given solvent having same temperature and pressure. It is called saturated solution. Matlab, the solute further cannot be dissolved in solvent. Optimum dissolution has been achieved. What is unsaturated solution? When the solute can be dissolved in solvent. So solvent can still dissolve or dissolution can still happen at constant temperature and pressure. It is called unsaturated solution. Now what will be the effect of temperature on solubility of solid in a liquid? When the dissolution is exothermic. What is exothermic? Liberating heat. So when there is a rise in temperature, solubility will decrease. How? With that heat, exothermic reaction gives out heat. There will be a shift in the equilibrium. The dynamic equilibrium will shift towards the left. Matlab, the solution will now give out solute, the crystal solute. The crystallization will be more. Hence the solubility will be less. So with rise in temperature in exothermic reaction, the solubility will be less with the increase in temperature. So when dissolution is endothermic means heat is absorbed. With the rise in temperature, solubility also increase because now the equilibrium will shift towards the right. Right means towards the dissolution. Dissolution means the solute will now be dissolved in solvent more. So when the dissolution is endothermic, the equilibrium balance shifts towards the right and hence the solubility will also increase. Next, partial pressure. So when a gas is kept in a closed container, it exerts pressure on the walls of the container. So gas pressure equal to force divided by area. The force exerted by gas particle on unit area. So see, this is a container, there are gas particles. Gas particles are bombarding on the container wall, creating force, and the force divided by per unit area is known as pressure. So this is the partial pressure created by gas when kept in a container. So Henry's law, let us discuss. With increase in pressure, solubility also increase. In the diagram, see there's a solvent and above it there's a gas that is solute. There's a piston. When I bring the piston down, I'm creating pressure. When the pressure is increased, the gas molecules dissolve in the solvent. Hence, solubility increases. So we can write it as pressure is directly proportional to solubility. or pressure is directly proportional to the concentration of solution, or pressure is directly proportional to x. What is x? Mole fraction. So what is mole fraction? It is the amount mole fraction of x, that is mole fraction of solute, equal to n solute. What is n? Number of moles of solute whole divided by number of moles of solute plus number of moles of solvent. Here in gas, so mole fraction of gas equal to number of moles of gas divided by number of moles of gas by plus number of moles of solvent, that is water. So if I am removing the proportionality sign and bring it to equal, I'll be putting a constant. So I'm putting constant at kh. What is kh? Kh is Henry's constant. Now Henry's constant actually depend on the gas from case to case. So Henry's law states that the amount of dissolved gas of a specified liquid is proportional to the partial pressure on gas in equilibrium with liquid at constant temperature. So partial pressure of gas increases, solubility will also increase. Next, Dalton's law of partial pressure. A container containing non-reacting gas molecules like H2 and O2. Non-reacting means these gases will not react with each other. So a container contains several non-reacting gases. Two, for example, have been given: H2, that's hydrogen, and oxygen. The container will exert two types of pressure. Pressure exerted by hydrogen gas and pressure exerted by oxygen gas. So total pressure, PT is total pressure, equal to sum of the individual gas pressure, that is pressure of H2 gas plus pressure of oxygen gas. So total pressure equal to pressure on the individual gases O2 and H2. So Dalton's law states that the total pressure exerted by a mixture of gas is equal to the sum of the partial pressure by the individual gases. For example, H2, hydrogen, is giving a partial pressure of 2 atmosphere on the walls of the container. Oxygen is giving a partial pressure of 3 atmosphere. So total pressure equal to 3 plus 2, that is 5 atmospheres. So that is the Dalton's law statement. So thank you very much. We'll be continuing with the chapter part 3. Please stay tuned, subscribe my channel, and do share it with your friends so that everybody can benefit. Thank you so much.